Hi guys, and thanks for watching again. In this video I will be building this power bank kit. It is a kit without the batteries. It can hold up to 4 18 650 style batteries. And I'm going to salvage them out of this old laptop battery. Now let me get this in focus. This laptop battery claims to have 18 650 style batteries, so that's a good start. So I know that they're in there. And this 4UR, my guess would be that there are 4 in there. It is fairly light, so 4 seems plausible. And it claims a voltage of 14.8 volts. That is, if we divide that by 4, we come around the 3.7 volts, which is normal for a 18650 style battery. But in this case, I would think there would fit at least 8 of them in there. 6 over here, 2 more over there. But it is too light for 8 batteries. So my guess is that there is place for 8, but they only stick 4 in there to save money, or this was a cheaper model or something. I don't know it yet, but we will see. So all we need to do is crack this open, and there are no visible screws. And let me push the sticky label in. There is indent over here, so let's, without stabbing myself with this screwdriver, what is there? That is, we do see that's a nice start. That looks like a 18650 cell to me. So let's see if I can crack this open without damaging the cell too much, of course. At least that's what I'm going to try. I'm gonna try. Ooh, that makes it a lot easier. But we do see, now I do see 1, 2, 3, at least I see 4 of them right now. Let's see if I can. Let's give it a little cut. See if it snaps. Yep, this shitty, cheap screwdriver gave up. And I hate these anyway. And while I'm at it, some time ago I saw a video of John Ward, and he made a video dedicated about these screwdrivers and just how bad he thinks these screwdrivers are. And I must agree with him. They are not particularly safe. I'm not saying that they're unsafe, but he just said, well, why would you want to make yourself part of a 244 volt circuit if you don't have to? Because that's what's happened. If you put this in a live socket, you hold this and there the neon starts lighting up. You made yourself a part of a live circuit. What if the resistor in there went short circuit? What if there is some water in there and you connect a live wire? You don't want that. You don't want to take that risk. At least I don't want to do that. And I must say, I have used them, of course. But yeah, I think John is right. And the reason I'm mentioning this is because there are lots and lots of comments on this video of people telling him that he is not, that he's just not right. That it is a safe device to use, and that they use it all the time. It was never went wrong, and yeah, that could be right, of course. But why take the risk if you don't have to, right? At least this one is dead right now, so that's a good start. This sticks. Right. Like I said, there is space for a lot of more, but they just saved some money by putting just 4 of them in there. Now, the colleague from which I got this battery, he told me that that the battery, there we go, died out very quickly. The laptop just went out within a couple of seconds when running on batteries. So my guess is just one of these cells is near dead. We can't use that. I have spares, of course, but let's see how good this power bank will perform. And my guess is that there are also temperature sensors in here. Let's see if I can get some batteries out while not cutting myself. I've cut myself in another video and I've still left a scar on my thumb of that video, so, and I don't want to damage these batteries too much, so let's make an incision over here. And, ooh, that was sharp. That was sharp. It's this plastic point, but there we go. Right. There we are. Temperature sensors, and only on one cell, not on these, and just empty barrel, right? All right. So let me prepare these batteries, and I'll be right back when we start building this. So there we go. Right. So these are the batteries cleaned. They're all lying with the positive to the left side and the negative to the right side. Let's see how good they are. What now? Let's say. How much juice is still left in them. 3.86 volts, 3 volts, so this one is discharged too far. 3 point, yep, and that is the malfunction of this multimeter. It is either 3.34 or 3.24 volts. At least it is discharged too far, and this one is even further. So this one is the worst battery of the series, but I'm gonna use them anyway. I'm gonna put them in the power bank, put them in here, and let's see how good it is, still is, and let's discharge and fully charge it and see how far we can actually charge and discharge it before these batteries give up. Now let's see, there is space in here, and not much, but there is some space so I can attach a wire. And of course there is no manual or anything provided with this power bank, but it was $1.95. It's actually a metal case, Xiaomi.com. It feels very nice. Only disadvantage of this very cheap one is it is only one output port, one input port. So yeah, if you only need to charge one at a time, that is no problem. And like I said, there's no manual, so my guess is that they all go in parallel. There's just 3.7 volts, 4.2 to 3.7 volts going in there, and then so they're not need to be placed in series like in that one. But if we look at this circuit board before we start mounting it all together, we do have a coil over there, indicator LEDs, a switch, probably the charge regulator, and nothing here. So this tiny IC will probably regulate the charge and discharge. It will monitor if the cells are full or totally empty. At least that's what I'm guessing, with only such a small IC. I'm not very confident right now, but maybe it works. And this is probably the step-up coil. If you look at this, this is the board which came out of the battery. It has way more electronics on there. These were the temperature sensors. Of course, it measured temperature, and this board was able to charge the individual cells, monitor the charge of the individual cells, and as soon as one of these gave up, this entire battery pack went down. So yeah, let's see what this very cheap thing makes of it. Now I need some wire. Yeah, I'm gonna find some wire to attach on the back and the front. The negative goes on this side, the positive goes on that side, and after I'm finished, it goes in there like that probably. Let's see. Yeah, it just clips in place. That's, at least that is my guess. Yes. Let's try that first without the batteries, because it isn't going in there very nicely. So it works. So I can do that again. Right. All right. Now it's my job to keep the wires as short as possible. All right. Like I said, I'm gonna find some wire. I'll be back in a moment. Now I found two pieces of wire which I salvaged from an old ATX power supply. They're rather short, but I will have to do all the wire I have in stock is too thin to my taste. It's probably good enough, but I like to use some thicker wire for these. So what I'm going to do, I'm going to solder solder the wire on the back. But let's first put a little bit of solder on there, but it needs some heat first. And yes, I know lithium-ion batteries don't like heat, so these might as well explode. It isn't taking heat, solder yet. There we go. But it is on that side, so let's cool it. Right, now I'm going to try, let's just use this piece. No, let's just use, let's scratch a little bit on the back side. There we go. Alright, then use some, oh, there's the other battery. A little bit of flux on there. And let's see if that goes any better. Let's see. That feels better. So now it doesn't have to take that much heat, and it probably sticks better than this blob. So that that worries me less. So let's tin this also. Right, that's tinned. But I'm going to need to strip it on here as well. This point. Oh. Now I lost it. So let's see if I can mark that somewhat. That's rather difficult. So it's not very important. This amount, about this amount. So there we go. So you can put it a little bit back. The insulation went over my soldering. I want to strip some more. Oops. Like that. Now I have a loose piece in there and I want to cut it away. So what I'm going to do, I'm going to snap it off like that. See if I can just pull it off. There we go. Now I want the insulation to go back a little bit, so I have to grip this point. That's better. Right. I want to tin this piece also. Now this wire is not happily taking the tin, but it has no choice as far as I am concerned. It is getting hot though, very hot. So there we go. What is wise? Let's start by this one. It's still hot. Let's see about the distance. This sounds like a good idea. Let's see if I can hold it like that. Oh, that is way too hot. Oh, but it is. Oh yeah, it is. The connection is good, so that's what I want. Let's see. Now the battery is dissipating the heat way too fast, so come on. It doesn't look pretty. Let's cool this lithium-ion battery. Yes, it is strong, so I'm happy. Oh, and I have to tin the other sides as well while this still is attached on there. Let's see. Perfect battery holder. That's good. So let's do what I did before. Now this will probably get very boring to see me fix all the batteries on there. So I'll speed it up and I'll come back to you as soon as I'm going to mount it on this board. Now I don't know if you're still watching, but if you do and you're doing this, make sure that now that the positive and the negative sides do not touch, these can still contain a dangerous charge. So when they short and you don't, well, and these wires get welded together, and you don't see it or don't smell it, it can get very dangerous. They will vent, probably even explode. So make sure that you work safe and always take care of these wires. So yeah, continue connecting these two positives and then mount them all on there, and let's see. Right, now let's see if I can get the board in, but before I do that I need to lift these batteries. And, well, let's get them out anyway, because if that makes contact somehow, I may just fry that single chip on there. So it is sitting in place right now, so that looks good. Let's put them back in there. And there is space on there. The battery minus it, and it just might touch the board on there. Well, I'm not very happy about it touching the board, but there is some separation there on that side. Let's see if we can get it out one more time without damaging it. What I'm going to do, saw some off here with a Dremel or something. This is the negative side of the battery is connected to all this green stuff over here. So when it somehow by friction it manages to touch, it will short these batteries and it will get hot and it will go up in flames. So I will modify the board a little bit. Let's find a Dremel. Now there is separation. Right, click that in there. Get the batteries in position again. That looks so much better. Let's see if we can get it in focus. That piece over there just was touching the board and now it isn't anymore. So now I'm happy. Let's double check everything. Only the insulation is touching the board. Should I remove a little bit more? Yes, I should. Let's see if I can get it well in the case. Now there's some copper wires. I will have to cut it out again. Now before I continue, because I modified the board and there's a thin line between the positive and the negative of the battery, I'm gonna test for continuity. Just see if these are shorted by my actions. I don't think so, but I just want to be sure with these batteries. There is some resistance, but that is okay. So there we are again, sitting in place. Modified board also in place. Now I'm gonna put the Dremel aside, put a nice blob of solder on there. There we go. And on there as well. That is the negative. Is my wire is it actually too short to reach it? Is it now? No, it is not. I will make it fit. So what will happen as soon as I connect it, the board will probably start up because there is some juice left in there, and probably some LEDs will start lighting up. Or everything goes up in flames, that's also a possibility. And I know you want that to happen. Oof. Yep, that was hot, and I damaged the insulation by doing so. But that doesn't matter, so there we go. White LED, one white LED, flickery. So it is doing something. What if I hold the power button, will it go off? No, it won't. At least it is doing something, and this is probably indicating that the battery is totally empty, and that is true because it is. What do we need to do? Is it still safe to insert because it's a metal case? Let's double check if everything looks good. There is proper separation there. It all looks good. Mounted steadily, mounted very firm, doesn't go anywhere. Batteries are in solid. Wire is not too thin. It's still straight, so it will fit. Let's see. While scraping off the insulation from the batteries. Right, so there we go. Looks nice, feels heavy right now. Let's charge it. Let's see, where do I have? Let's charge it with this one actually, and I'm not gonna plug it in my PC because, well, I haven't tested it yet, and just doesn't sound like a good idea. So this was goes to the output port, and this goes on there, and it is charging, and it's still not very hot, so the batteries are working. Now I'm not gonna this one single 18650 style battery, and it is of course not able to charge these all. But what I'm going to do, I thought there it is. Gonna see how much goes in there and fully discharge it with probably a load or something, a dummy load, which I have over here, and see how much comes out, and then we know how good it still is. There is 10,400 milliamp hour listed on there. Could very well not be the case because I only inserted 2000 milliamp hour batteries, which make that a total of 8000 milliamp hour. But yeah, let's see what it does. So I will record in the next coming hours and see how good it is. For now, thanks for watching. Now here's a quick update about this power bank I just built with 4 batteries in it, 4 18650 batteries with 2000 milliamp hours each. It took this device, which can handle 2 amps, almost 13 hours to fully charge. It stopped charging at around 100 milliamps, and it is now holding 6670 milliamp hours. Of course, it is not holding that because there was energy lost during the charging with heat, resistance, anything. But it started charging with around 900 milliamps, and then it went down 800, 700 until it was sticking at 200 milliamp hours for quite a long time. That's why it took so long. And yeah, I guess all the batteries evened out somewhat because one was quite flat and the other ones were somewhat better. So my guess is that they're evenly charged right now, and let's see how the discharging goes. I'm using this device. It can handle 3 amps. I'm not going to put it on 3 amps because that will probably destroy this one. Put it at around 1 amp or so, and measure again how much there was actually in there, or how much this thing is able to use. I don't know if I can make a video update about it, but if I am not able, I'm going to put it in the description. So again, thanks for watching. Now here's another quick update because I wanted to test this and wanted to show you this. I've currently set it to about 1 amp, 980 milliamp hours. There it was 1 amp. Now it's only capable of putting out 4.8 volts right now, and I'm gonna turn it up and see when it will cut off. 4 LEDs are lighting up. That means it is full. Each LED represents 25%. Now the fan starts spinning because it is getting quite warm. This power transistor here is, yes, it is getting quite warm. Let's see what will happen. I hope you can read it. Let's put it in mid-air, why not? There we go. 1.15, 1.2 amps. The voltage is dropping very fast right now. 4.3 volts left, 1.5 amps, 4 volts left, nearly, and there we are. It cut off. Is that expected behavior? So let's see. DC, I'm not sure about that, but I would suggest that it is able to put out 2 amps and not the 1.5 where it cut off. So, and my guess is that it is not the batteries which are unable to. Now it's not working anymore because it's cutting off immediately. There's some LED flickering over there. Let's turn it back, turn it down, let's see if it comes up again. There we are. So yeah, my guess is that it is not the battery which is the limit, it's just the tiny circuit board in there which limits the amount of the current. Oh, let's turn it back to 1 amp and leave it discharging for a while and see at what milliamp hour setting rating we can get. So there we go.